Discrete temporary annuities. When we want to find the APV of the discrete temporary annuities, we can use the similar approach of the whole life annuities. It's just that now it will end at the maximum term, which is N. So let's assume that the payment is $1 every year and it will be made up until N-1. So we know that this is annuity dues. Okay, and then the presence value of the random variables, let's say that it is equals to y, and then y equals to 1 minus z over delta, where your z is the v to the power of kx plus 1 if it is lesser than n, and then v to the power of n if kx is greater than n. If, let's say, death happened here, so that means that the annuities will already be collected here, or the payment will already be made here. So anyone that is dying in this period will have to pay, or will have to collect the annuity from this term, which is 0 up until n years. So we can say that the expected value of y equals to 1 minus expected value of this, which is, let's rewrite again to make it clearer, expected value of 1 minus z over d, which is expected value of 1 is 1, expected value of z is the endowment here, so you are going to get 1 minus ax n over d. And for the variance of y, you are going to get equals to ax n minusing ax n to the power of 2 over d square. There's another approach to determine the presence value of this annuity, actual presence value of this annuity, which is by using the timeline and draw the probability and discount back one by one. Let's say this is year up until year n-1 and then n. So let's assume that the payment is $1 every year. So the discount factor is 1 v square v cube v n-1, and then the probability would be 1. Probability of receiving or making this payment would be px, here is 2px, 3px, and then here would be n-1 px, and so on. So expected value of y here is summations of all of this up until n-1. So you are going to get 1 plus vpx plus v square 2px plus v to the power plus v to the power of n-1 n-1 px. So we can rewrite it as, in a simpler way, k equals to 0 up until n-1 v to the power of k px. This is the annuity due. So the actual notation for this case would be a double dot x n, where your n is the term and your x is the age. If you want to look into the immediate annuity, so let's change the color to this one. Okay, So for annuity immediate, there will be no payment here. Here, no payment. Here will be the same, but there will be additional payment up until n. So here will be n. The amount of payment will be 1 v to the power of n and px. So from here you can see that a xn, there's nothing, no dot above a, which is annuity immediate. And then same here, your n is the term and your x is the age. This is equals to a double dot xn minusing this part, minus 1 plus with vn and px. Okay, that's it for the temporary annuity. Thank you.